Okay, so in the previous lessons, we have solved the roots, the zeros, or the x-intercepts of an equation or function. Now we're going to go in the opposite direction. We're going to create the equation or function given the roots, the zeros, or the x-intercepts. Anything we can do one way in math, we can do in the opposite direction as well. So, looking at the beginning, since x minus 3 is a factor of the equation, then that means that positive 3 is going to be a root of the equation. Since x plus 6 is a factor, then negative 6 will be a root. If I reverse it, if I said that 3 is a root of the equation, then x minus 3 would be one of the factors. If I said negative 6 is a root of the quadratic equation, then x plus 6 has to be one of the factors. So if both 3 and negative 6 are roots, then the equation could be x minus 3 and x plus 6 equal 0. If a quadratic equation has roots of m and n, we can say that it must be in the form of a bracket m minus n, x minus m bracket x minus n. We've already seen this factored form for our functions, where the m and the n were the x-intercepts, or we could say that the roots could also represent m and n. The zeros could represent m and n as well. So, in each case, the roots of the quadratic equation, ax squared plus bx plus c is equal to 0, where a is equal to 1, are given. Write the equation in the factored form, and then expand it out into the general form. So, to begin, for the first one, if negative 7 is a root, then x plus 7 has to be one of the factors. Or if positive 1 is a root, x minus 1 has to be one of the factors. And when I multiply them together, that's going to equal 0. In order to put it into the general form, I'm just going to FOIL this out. I'm going to multiply the x and the x and the negative 1, the 7 and the x, and the 7 and the negative 1, to get x squared plus 6x minus 7 is equal to 0. In the second case, if the roots are negative 2 and negative 3, then I could say that this would be x plus 2 times x plus 3 is equal to 0, and then I'm going to FOIL it out to get it into its general form as well. I would say that this would be x squared plus 5x plus 6 is equal to 0. In the last case, if I said that it was 0 and 4, well, then one case would be x minus 0, and the other case would be x minus 4 is equal to 0. We really know that x minus 0 is redundant. It would actually be x times x minus 4 is equal to 0, because minus 0 doesn't actually change the value. And then when I multiply it out, I get x squared minus 4x is equal to 0. There's my factored form. There's my general form. If I'm using the x-intercepts to determine the equation, I'm going to do a similar process. Consider the equation that's shown. 2x minus 1 times 3x plus 4 is equal to 0. They graphed, replaced the 0 with y, and graphed out this function, and we can see the graph of the function right here, where we can clearly see that it has two x-intercepts. One is at negative 4 over 3, the other one is at positive 1 over 2. So, since 2x minus 1 is a factor, then 1 over 2 is an x-intercept, or the point 1 over 2 and 0 is going to occur on the graph. Since 3x plus 4 is a factor, then the point of negative 4 over 3 and 0 is going to be another x-intercept that is going to occur. If I know that 1 over 2 is an x-intercept, then 2x minus 1 is going to be one of the factors. If I know negative 4 over 3 is an x-intercept, then 3x plus 4 is going to be one of the factors. So if I know both the x-intercepts, then I would say that 2x minus 1 times 3x plus 4 is going to be the equation. Notice that if the x-intercept is 1 over 2, we're going to use the 2x minus 1 instead of x minus 1 over 2 in order to put it in an integer form. The way we do this is if I said that the x-intercept, or x, was 1 over 2, the first thing I would do is multiply both sides by 2. 2x is equal to 1 to get rid of the fraction. And then I would move the 1 over in order to get the factor that I'm looking for. In order to express a quadratic equation in factored form, Michaela graphed the corresponding function and determined the x-intercepts to be 3 over 5 and 5. Well, if I'm determining a possible equation in factored form, I would do the same process. I would say that in one case, x is equal to 3 over 5, so I'm going to multiply both sides by 5 to get rid of the fraction. 5x is equal to 3, or 5x minus 3 is equal to 0. And there's one of my factors. The other one was when x was equal to 5, so x minus 5 is equal to 0, and there's the other factor. If I'm putting it in factored form, I'm going to do that first. I'm going to say that 5x minus 3 times x minus 5 is equal to 0, and there's my factored form. When I multiply it out, I'm going to get my general form, and I'm going to FOIL this out just like I would any other one. I'm going to say that's going to be 5x squared minus 28x plus 15, when I FOIL everything out, is equal to 0. If I'm using the zeros to determine it, then it's going to be the exact same thing as when I use the roots and when I use the x-intercepts. So in order to express a quadratic equation in fact form, Chris determined the zeros of the corresponding function to be negative 3 over 4 and positive 2. If I'm determining what the equation is in general form, I'm still going to start by putting it in factored form. So if x is equal to negative 3 over 4, then 4x would equal negative 3, or 4x plus 3 is going to equal 0, and there's one of my factors. If x was equal to 2, then x minus 2 was equal to 0. There's the other factor. I always have to start by putting in that factored form. 4x plus 3 times x minus 2 is equal to 0, and then I could multiply this out and get 4x squared minus 5x and then minus 6 is equal to 0. Now, we found in the past if we need to write a different quadratic equation which satisfies the conditions, then we found in the past that if we had a coefficient on the outside, so I factored it down, I had the factor, and I had a common factor on the outside. Say 2, 4x plus 3, and x minus 2. Anytime that I had a common factor outside of the brackets, this did not change what the answer was. It changes the shape of the graph, but it doesn't change where the x-intercepts occur, doesn't change the zeros, doesn't change the roots. Which means that if I want a different equation which satisfies the conditions, I could literally take my general form or factored form equation and multiply it by any number. Multiply every single term. So I could literally double every term in here and say that if I had 8x squared minus 10x minus 12 equals 0, this is still going to have the exact same roots because when I factor it into this form, where the x's are still has the exact same values for the factors. The 2 on the outside is not going to change the answers.